Hey, Adam. Thanks for joining me here.
Hey,
Really excited to show off a couple things with Karpenter that I just wanted to do it real quick, give everyone a taste of kind of what it can do. So absolutely, I love that you're here. So you can feel free, ask any questions, and let's just jump right in. And I want to show off a couple things here. I got this is Cube Ops View. If you've never played with it before, really cool open source tool. Right here, I have on the top a cluster that is using the cluster autoscaler, the Kubernetes cluster autoscaler, which a lot of people know and love, and it's just a great way to autoscale your clusters. And on the bottom here, I have a cluster with Karpenter to do autoscaling. So they work a little bit different, and I, again, being a visual learner, like always, I like seeing it to be able to understand it and saying, okay, what actually is going on here. And one of the things that Karpenter does, which I think is really cool, is it can provision nodes for anything in your cloud provider. Right now, it's using AWS, obviously. So if we wanted, say, a GPU instance, I could just deploy a workload that says, I need a GPU, and Karpenter will make it for me. And the traditional way with cluster autoscaler is typically you have to make a node group with a certain type that has those capabilities, and you would target that node group, and you would say, okay, I need to scale this up, and then cluster autoscaler has to be tied to that node group to be able to scale it up and down if you wanted to scale to 0 or something. So with Karpenter, it works a little more intuitive, more of a kind of Kubernetes way of scaling that. So I'll just show you real quick. I have a template right here of, oh, it's way too small. I thought I had it big enough at first, but
that's perfect, I think.
You got it? Okay. So really all I'm doing here is a standard Nginx deployment. Nginx needs all those GPUs. But what I have here is I just say, give me a resource of GPU, right? Like that's what I need. And so when I do apply that file, it's going to create me that deployment, which is going to create me those 4 pods. I wanted replicas here, and it says I need some GPUs. My existing node didn't have any GPUs, so Karpenter looks at that and says, "Oh, well, you need." Sometimes this refresh doesn't work so well, but it'll come in just a second. Don't worry. But what Karpenter is going to do is going to look at that and say, "Oh, this needs a GPU. I don't have any nodes that have GPUs right now," so it just goes look at AWS. Okay, where's a GPU node? Find out the resources that I wanted on the deployments, and then actually just find the best fit size for it as well. So it's not structured to like I need a specific size. It just says like, well, let's look at everything that has a GPU that can be attached to it, and then put those 4 pods on it. And Karpenter will do that for me automatically.
So Karpenter knows the instance families, the instance types, and it's going to figure that out. I don't even have to be an expert in instance types. Karpenter is the expert there.
Right, exactly. And traditionally, you had to know a little bit about your node groups or your autoscaling groups to say like, okay, well, this will fit these types of jobs, or if I want to fit, like 5 jobs per node or something, you had to know a little bit about like how to scale those autoscaling groups and the node groups. And so with this, you actually don't have any node groups. It's just EC2 instances, EC2 attached to a Kubernetes cluster. So it makes a lot of those things just a little simpler to say like, oh, well, this node needs these pods. Let's join it to the cluster. And man, this view's not coming up right now. Hold on a second. We're going to get it back. But one other thing that I actually want to show is this matters at that small scale of what does it look like for a couple of different instance types. The thing that I really find interesting difference here between cluster autoscaler and Karpenter is at like a certain scale. Once we start deploying hundreds or like a lot of pods, the way Karpenter is going to pick the instance types and the way cluster autoscaler is going to pick them is very different. And so in my testing originally, I was deploying 500 pods, and I would get 71 nodes with cluster autoscaler, and I got 7 with Karpenter. Whoa. And I got all the jobs running, but it was a factor of 10 that actually like Karpenter was just like, well, I can just use bigger nodes, fit all the pods on there, which helped in a lot of different ways of just like getting the pods there, overhead for like daemon sets, and then also just cost, because paying for 71 nodes versus 7. Sizes are different, pricing is different. It'll look different for everyone's cluster, but it was really cool just to see that. Like I had a 20% price reduction on that test. So it was really cool. I'm really hoping this is going to come back, but for right now, I'm going to actually just go ahead and deploy those 500 pods and show you exactly what I get here.
And so First of all, with what you just did, really amazing. You have no GPU instances in your cluster. Like, you have no GPU node groups. Karpenter figures that out. And then going back to this next point you made, as you're deploying these 500 tasks to each cluster, am I understanding you correctly, Justin, that Karpenter is going to not only figure this out, but what if I say, Karpenter, I want you to only use these sets of instances? Like, I have a preferred instance family that I want to use. Can I set that in Karpenter?
Absolutely. Karpenter uses a CRD called a provisioner, which you can set rules on it. And you can say, oh, well, I actually only want, these 5 node types, or I only want these regions, or you can set those sorts of limits on the provisioner CRD. So it's a native way to be able to say, like, I want spot instances. I want launch types that are spots. And then you can pick and choose those based on either the provisioner. So you can have Karpenter has multiple provisioners, or at the workload level, you can override the provisioners. So it helps in a lot of ways just to be able to be flexible there and say, like, oh, well, does the workload need this, or does the, globally, does the provisioner need this? And you can set those things. So it's really cool.
That's awesome.
So you can see I actually lost my second cluster. Hold on, it'll come back. Don't worry. There it is. So these are, I deployed 500 pods in this top. Well, actually, my clusters are overlapping now, which is pretty amazing. I don't know how that actually happened.
But I think it's pretty easy to see the distinction between the two.
I'm gonna refresh it real fast, and hopefully that comes back. If not, I have a backup over here. Okay, nope, it's just gonna do it. So these 5 nodes here on top, you can see have a ton of pods on them because they're very large instances. I don't even know what types it picked. Let's see, I can hover over it and see. This is come back. It's kind of freaking out because it's doing so much right now. C5 9XL. C5A 24XL. So I mean, these are really large instances, and it's just okay. Well, we can actually fit a lot of pods on there. Whereas in the cluster autoscaler, this is tied to my node group, and even here, my node group has a lot of different instance types in it. I didn't restrict it to a certain type. I restricted it to a certain size of CPU and memory because cluster autoscaler, you have to keep those kind of consistent sizing for that scale outs. Whereas in Karpenter, I don't have an autoscaling group. I don't scale on that metric. I can scale based on how many pods I can pack into the cluster. And so in this case, cluster autoscaler, it's still going. I think it scaled up all of my pods there. So I can see here I got 5 in Karpenter, and I can't count them because they're behind, but a lot of different instances with cluster autoscaler. And it's just a really cool, I love the visual of it to say, like, oh, I understand that difference now of how things are auto-scaling. And one of these is probably actually my GPU instance. When I think about it now, like I bet my GPU came back in here and it's showing up as probably having just a few pods on it because it, might have been reserved for the GPU. So, but that's really it. Like, I just wanted to quickly show off how that looks, what the scale looks like, and why Karpenter's a little bit different here than a traditional cluster autoscaler, and why people might want to look at it. Because, I mean, it's great. Both can scale up really quickly at a certain size. I'm going to start hitting different limits inside my cluster for how many nodes I can be talking to the API server. I'm going to start hitting overhead for how many daemon sets I have running, where this is a factor of 10 difference of how much I'm paying for daemon sets to run versus workloads in this example. So just really cool, kind of, thought it was great. This is the beta release of Karpenter. We have a lot more to try out if you want to get started. Karpenter.sh is the website. We got docs over there, getting started, or it's also open source. The whole thing, open source, right up on GitHub. So AWS Labs/Karpenter, kick the tires, open an issue if you have a use case, and let us know.
Excellent. Well, that was fantastic and amazing to see the difference there. Super cool. Get started with it. Check it out, Karpenter.sh.
Yeah, thanks. Bye.